All right, let's dive right in. Today, we're going to tackle one of the biggest, most important decisions that any company has to make these days, picking the right data architecture. I know, it sounds super overwhelming, but don't worry, we're going to break it all down into a really clear, straightforward framework. Let's get to it.
So you've heard all the buzzwords, right? Warehouse, lakehouse, data mesh. Maybe you've heard about real-time streaming too. It's a pretty confusing landscape, and there's a ton of pressure to get it right. So which path do you actually take? That's the big question we're here to answer.
And let's be super clear about this. This is not just some techie decision. It is a fundamental business decision. The architecture you build today is either going to empower your organization for years, or it's going to constrain it. We're talking about something that affects everything from your analytics and AI all the way down to your bottom line. The stakes are definitely high.
Okay, now here's probably the most important thing to get straight right from the get-go. There's no magic bullet here. There is no one-size-fits-all solution. The best architecture is the one that's best for you, for your specific goals, your data, and of course, your budget. So let's just throw that idea of a perfect universal solution right out the window.
So if there's no single best answer, where on earth do you even start? Well, the answer isn't with the technology. It's right here, with your business goals. You got to think of them as your compass for this whole journey. Every single technical choice you make has to point directly back to what the business is actually trying to accomplish.
And that means you have to ask the right questions before you do anything else. Like, who's actually going to use this data? Is it for your analysts who need slick dashboards? Or is it for your machine learning teams who need to get their hands on raw, unfiltered data? And how fast do you need the answers? Is getting a report tomorrow morning good enough? Or do you need insights in milliseconds? Answering these questions first is what's going to lead you to the right architecture.
Okay, once your business goals are crystal clear, it's time for step 2, mapping the terrain. This is all about taking a really good look at the data you're actually working with and defining the specific outcomes you need to get out of it.
And you can see here, the very nature of your data kind of pushes you in certain directions. If you're working with clean, structured data, neat rows and columns from a database, a classic data warehouse is a fantastic fit. But if you've got messy, unstructured stuff like images, text, or social media posts, then a data lake is going to be your friend. The big difference is what we call the schema, basically the formal structure. Whether you have one up front or not is a major fork in the road.
And this next part is all about connecting those business needs to actual real-world solutions. So if your main goal is creating BI dashboards for your execs, a warehouse is purpose-built for that. But if you're getting into the world of AI and machine learning, you're going to need the flexibility of a lake or a lakehouse. And for something like real-time fraud alerts, whoa, that's a whole different beast. That requires a specialized streaming setup with tools like Kafka and Flink to get you answers instantly.
Okay. With that foundation laid, we can get to the main event, a head-to-head comparison of the major architectures. This is where we actually get to choose our path.
For years, the big debate was always warehouse versus lake. Think of a warehouse as a perfectly organized library, for structured data. It's amazing for high-performance BI. A lake, on the other hand, is like a giant reservoir of raw data in any format you can imagine. It gives you incredible flexibility for exploration and AI. Understanding this basic difference is really the key to getting the more modern hybrid approaches.
This matrix right here, this is your decision-making cheat sheet. Just look at the trade-offs. A classic warehouse, it gets a big red X for AI support, but a green check for BI. The data lake is basically the opposite. Great for AI, but governance can be a real headache. Then the lakehouse comes along as this awesome hybrid, checking the boxes for both AI and BI. And then you've got data mesh. This is a newer idea where individual teams own their data like a product. It offers amazing governance for huge companies, but as you can see, it comes with a high price tag and a lot of complexity.
All right, enough theory. Let's get practical. What do these architectures actually look like when they're out in the wild? Let's go from theory to practice. Your company's size and how mature it is plays a massive role here. A startup is probably going to start simple with a cloud warehouse like BigQuery, just to focus on getting BI right. As they grow, they might add a lakehouse to handle more complex data and maybe some AI projects. In a huge enterprise with tons of different business units, they're going to naturally move towards something like a data mesh, so individual teams can have real ownership over their data.
So let's paint a picture. Imagine a retail company. They pull in structured sales data from APIs and databases. First, they land all that raw data in one spot.
Then they use a tool like Spark to clean it up and transform it. From there, it gets loaded into a cloud warehouse like Snowflake, which is built for lightning-fast queries. And the final step? Analysts hook up a tool like Power BI to build their sales dashboards. See, it's a really clean, straight line, perfectly designed for business intelligence.
Now, let's flip the script completely and look at a bank's fraud detection system. Here, speed is absolutely everything. Transactions are streaming through Kafka, they're processed in real time by Flink, and they're fed instantly into a machine learning model. If fraud is detected, an alert goes out in milliseconds. It's a totally different pattern, and it's driven by a totally different business need.
Of course, no matter which path you pick, you've got to pay for it, right? So how do you keep those costs from just spiraling out of control? Well, it often comes down to some really simple but super effective tactics, using compressed file formats like Parquet, moving old data you don't use much to cheaper storage, and really taking advantage of the pay-as-you-go model that cloud services offer. These small tweaks can have a massive impact on your bill.
And we absolutely cannot forget about security and compliance. Please, these are not afterthoughts. They have to be baked into your architecture from day one. That means defining who can see what, encrypting everything, tracking data lineage for audits, and making sure you're compliant with regulations like GDPR. This stuff is completely non-negotiable. So let's pull all this together. The final step is to design an architecture that doesn't just work for you today, but is actually ready for the journey ahead.
This flowchart basically sums up the entire process we've just walked through. Think of it as your repeatable playbook. Start with the business, analyze your data, figure out your governance needs, and then, only then, do you pick the architecture. The last steps are all about planning for growth and keeping a close eye on everything to make sure it's running smoothly.
This all boils down to a few key principles for success. First, start simple and let your system evolve. Don't try to build the Taj Mahal on day one. Second, realize that the best solutions are often hybrids that find the right balance between cost, speed, flexibility, and security. And maybe most important of all, this has to be a team effort between your business folks and your engineers.
And that brings us to our final and most important takeaway. A great data architecture isn't about using the flashiest, coolest new tech. It's about building the simplest thing that actually serves your business goals and can grow with you over time. So the final question you should be asking isn't, what's the best architecture? It's, what's the best architecture for our future?